in drawing 2. Actually, this is a chart, a flow chart. At very first stage, you have learned engineering drawing, then descriptive geo, then machine drawing in AutoCAD, machine drawing 1, and now machine drawing 2. So this is the thing where we want to reach. Here in this subject, we will learn how to, when we will draw it after export, we will directly can give this sheet to the manufacturing unit. The unit who will be responsible to manufacture that component. So in this drawing sheet, you will have all the necessary information which is required to make that component by using manufacturing technology. Okay. So what should be there in the drawing sheet? You know, in engineering drawing that you have learned there are different type of projection methods. You have learned that there are top view, side view, front view, and depending on the object, depending on the orientation, different type of views have been chosen. So all those knowledge is required here to draw an engineering component which is right now in use in different machines. So here we will learn to draw machine components with all the necessary details, and we will draw it in AutoCAD. When AutoCAD was not there, this subject was also there in the mechanical engineering syllabus. But in that case, this type of drawing students have to do in drawing sheet. So that was a very rigorous process. So right now, when we use AutoCAD, it becomes easy, but still it requires the knowledge of processing the total drawing ideas. Okay, you have to use different lines, different views. You have to imagine that which one is hidden, which portion is not visible, from which side. All these things you have to consider. So before starting about one engineering component, which I will discuss today, I will tell you the way how this class will go on. First thing is that you are already in the classroom. So after everyday class, I will give you an assignment in that classroom. You have to submit that assignment in A3 template PDF format in that classroom assignment portion. And I will give you the time for 1 week to complete that thing. In this way, we will learn to draw 6 to 7 different engineering components as per our syllabus. So today the component which we will learn, that is called stuffing box. Okay. About that, definitely I will start to discuss. But do you remember that how to make the page layout in AutoCAD, how to make template,
Yes,
how
sir.
to you remember all those things. So that is not required to tell. Okay. So directly I am starting it. So my screen is visible to you.
Yes, sir.
Yes, sir.
Okay. So this is the component which we are going to draw. Name of this component is stuffing box. Okay. And the purpose is that it is used in palm for sealing purpose. Mainly it is used in centrifugal pump. And its purpose is that so that something can go outside with the shaft. Here something can come inside with the shaft. So purpose is sealing. So shaft may reciprocate, may rotate in different environment, but there will be no leakage through the shaft from the inside chamber to the outside chamber. This is the purpose. So we will not go in depth that how it is used, where it is used. Definitely, I will tell you where it is used, but it's that application orientation in that depth we will not discuss here because that is not our scope here. We will learn how to draw it. Okay. Main application, this is a figure uh, where it is used. You can see this part is Ulis part, which is in the top. You can see it here. Okay. So what is the thing? What it is doing? Something is happening inside this cylinder. Okay. And target is that the component which is there inside the cylinder will not come out with the shaft. Okay. This shaft may reciprocate. Yeah, it rotates. So if there is no sealing mechanism, suppose inside there is steam. So if there is no sealing mechanism, because shaft is the only thing which is connection between inside the cylinder and outside the cylinder. So if steam is there inside, suppose, then there is a chance that steam will come out with the cylinder. Small gap definitely will be there. If this is only shaft and a cylinder, there is no sealing mechanism, then a small gap definitely will be there. And with that gap, steam can easily come out. There will be a leakage. So to stop that, to prevent that, in the joint where the shaft is coming from the inside cylinder to the outside environment, this stuffing box is used. It will restrict the movement of the steam or fluid which is there. Okay. Similar thing. This is another application. There may be propeller. Someone came. One. There may be a propeller in the boat, and in that case, our target is so that no water can go inside the boat. There should not be any leakage with the shaft from water to the boat. So in that way, it is also sealing, because here also the connection between water and boat is shaft. Some portion of the shaft is in the water and some portion of the shaft is inside the boat. So water should not go inside the boat along with the shaft. In the junction, there should be this component, this stuffing box. So what is its purpose? It is clear. It is restricting the leakage. It is restricting the leakage of steam, yeah, fluid, yes, anything, that type of format. Now, here, if I tell you to draw this component, and if you draw only the top view, front view, and side view as it is, then most of the information is not being drawn, because major features in this component is inside. What you are seeing from the outside, that is actually a cover of some components which is already there. And this one, this grayish one, this one is the shaft. So one, this is one cover, this is another cover, and these two things are called stud. These two are nuts. So what you are seeing from the outside, that in this component there is one body which is right now black in color. There is one body which is yellow in color. Two studs are there, grayish. Two nuts are there, and a shaft. This is the visibility of this component from the outside. Now, from basic concept, if you want to draw it, then you will get a top view, you will get a front view and side view, and that is very simple. You can draw it from your first year knowledge. But I am telling you that when you will draw it without cutting it, you will miss the major components, major features which is inside it. Okay. So for that purpose, this type of components we have to draw either by half section, yeah, by cutting 1/4 of it, in that way. Either we have to cut the total assembled component in a half section view. Otherwise, we can take individual component and we will draw it. And assembled view we can show after cutting it. Then only this drawing of this component will be completed. So individual components we have to draw, because what is visible from the outside, other than that, there are some components which is also there inside. So we have to draw that thing individually, and otherwise we can cut it and we can draw it up section view. Okay, in these two way we can represent this drawing. So when working drawing of any component will be said, then it means that you have to provide all the informations with its material and how many components are there, individual components are there in this total stuffing box component. Okay, suppose there are two starts which is visible. So when we'll draw the start, we have to mention that the quantity is 2. How many starts should be there? And for the purpose of individual component drawing, only one drawing of one start is sufficient. But the quantity we have to mention. Similar case is also for the nut and for other parts also. That's why here the components have been listed. There are total 6 components which is there. Body is visible, which is made of cast iron. Gland is visible, which is made of cast iron. This blackish part is called as body. This one is will be called as body. Body of the stuffing box. In some book or in some places, you can see that component of stuffing box, the first component they have written as stuffing box. So this portion, if you call it as stuffing box, then that will be ridiculous. Because stuffing box, one component of the stuffing box is stuffing box. This is not a right way to present. So we will call it as the body of the stuffing box or main part, yeah, main body, yeah, main portion of the stuffing box. And this is made of cast iron, this blackish one. The second one is the gland. Gland is this yellowish one. Okay, this one is called as gland. And these two main part which is visible from the outside is made of cast iron. Third part is neck bush, fourth part is gland bush. Okay, so neck bush and gland bush is not visible from the outside, it is there in the inside. Okay, neck bush is actually lie here in the bottom. In the bottom there is a bush. When shaft is actually ending, yeah, shaft is first entering into the stuffing box, at that place there is a bush which is called as neck bush. And gland bush is another bush which is there inside this gland. The height of the gland bush is equal to the height of the gland, but the neck bush, the height of the neck bush is not equal to the height of the main body of the stuffing box. The height is small, but it will be placed at the bottom of this main body part. Two bows are there. What is the purpose of the bows? The purpose of the bows is it will reduce the sliding effect when shaft will rotate. Yeah, when shaft will reciprocate. It means that with respect to this gland, yeah, with respect to this body, there will be relative movement of shaft, and if there is no structure in between them, then a metal to metal contact will be there, and due to that there will be friction, and due to friction there will be heat generation, there will be loss of material, lot of things may happen. So it will ultimately damage the body part as well as damage the shaft. And shaft is a very important item and it should not be changed in a machine components continuously. Okay, we have to protect it. So in that case, boost is used so that it will reduce the effect of the friction. So two boosts is there, neck boost, gland boost, and other two parts which is already visible from the outside, that is start and nut. So what is the thing which is not visible from the outside? That is neck boost and gland boost. And when you have to adjust the boost, then internal features also should be designed in that way, so that boost will be fit inside it and then shaft will be fit inside the boost. So design when we have to draw it, when we have to design it, then we have to choose the dimension of the body and gland in such a way that at first there will be the body. Inside the body, definitely there will be a hole, but hole will be in such a way that bush will be fit in that hole. So the design of the bush will depend on the hole. And this gland, small portion of the gland is also inside this main body. So this diameter of the gland also should be matched with the internal diameter of this main part body. Inside the gland, there is a gland bush. So the internal diameter of the gland should be matched with the outside diameter of the gland bush. And inside the gland bush, there will be a hole where the shaft will be matched. Okay. So what are the factors we have to keep in mind? Again, I am repeating that this is the main body part. So there is a hole, and in that hole, bush should be fitted, neck bush. Inside that neck bush, this shaft rod should be fitted. Also, along with that, this hole should be in such a way that this gland should be fitted, and inside the gland bush should be fitted, and inside the gland bush, this shaft rod should be fitted. And in all this way, this rod will be continuous straight line from bottom to top, and it will rotate, yeah, it will reciprocate. This is the total design aspect in terms of this stuffing box. Other than that, what are these two? This is two studs and nuts, and this stud always has two parts. One is longer, another one is shorter. Okay, this longer part also has a thread. The shorter part also has a thread. The shorter part will go inside this flange of this body, and longer part go through the flange of the gland, and by using nut we will tighten it, and this gland will be properly tightened with this main body part by using these two stud and two nuts. So these are the total components: one body, one gland, one neck bush, one gland bush, two stud, two nut. The material is also written: cast iron, brass, mild steel. Now, what are the features and assembly? The features and assembly, the most of the things which I have already told you. The main body is made by cast iron, and it is as cast. Cast means that casting technology. So the total body has been made at a single component. There is no joining, nothing like that. This is a single component which is made, that body part. Okay. Now the shaft, the body, see here in this main portion, this is the shaft and this is the body. Okay, you can see there is a large gap between the diameter of this body and this shaft. The gap in between this internal surface of this hole inside the body and the shaft, that gap will be filled up by some absorbing material. Okay, like asbestos, like fibers, like that thing. So if any small leakage will be there, then it will be absorbed by those packing materials. So packing materials was there, will be there definitely in between that shaft and the internal surface of this main body part. Okay, and that packing material will not be drawn in our drawing portion, because if I show the gap, then that is sufficient to give the information. That is not our job to specify that uh, the design of filling material. That is very simple, and that will not come under a drawing part. So that is the packing material or sealant, you can say, that will be filled up there, and two stud nuts are there, that is written here. Bushes are there, which is made of brass, and The purpose is already written here. Written means I have written it, the purpose. And this bush also the wear out, the material loss, if anything happens, that will be happen on the bush. So actually in that way we can change the bush here. So the changing of the shaft, yeah, changing of the main body part is not required. That's why bush is used. There will be a slope, and that slope is used so that it can be tightly packed, and that slope also should be visible when we will draw it. The slope of that bush and slope inside the gland. Okay. There should be something where oil will be put on the top of the gland. The structure will be like that. The flange which we are seeing here, this flange is actually for two studs. There may be some design where this flange will contain three studs. Then it will be triangular, and if there are more than three studs, then it will be circular. Okay. By using nut, we will tighten it, and this gland bush which I was talking, this gland bush, it is not required if the size of the stuffing box is very small. In that case, this gland bush will not be required. Gland is sufficient there, because there will be enough gap between gland and the shaft. Shaft rod. Okay. So if there is no touch, because it is already tightened in the neck bush and it is already tightened by the sealant, so there will be a gap between shaft rod and the inside periphery of that inside surface of that gland hole. So in that case, there will be not direct touch, and in that situation, gland bush is not required. So this is the optional one when the stuffing box is very small in size. Otherwise, these components will be definitely there. Okay. Now we have to draw it. And what is the assignment which you have to draw? This is a figure of the stuffing box in a sectional view. Okay. What is this here? What I told, see, these are the holes, one here, another one here. These are the holes for moving the stud, which is already there in that side, which is not cut. Okay. This is the gland up to here. This is the gland. And you see there is a small gap. Wait. You see up to here, up to this line. Okay. Wait. Up to this line, it is your top of the main body, and gland ends here. This one here, the gland ends. So gland has gone little bit deeper in the top of the main body, not total, but little bit. Okay. So the main body part ends here, and gland starts here in the assembled position. When everything is assembled, then gland will end here and main body part starts from here. So it will enter inside that hole of the main body part little bit, very little. If the total length is 16, if this total length is 16, means thickness of the flange of the main body part, then we can take it as 7, yeah, 8 like that. Okay, 7, 8 up to that. This portion is gland bush. This one. You see the difference in the hatching. This type of hatching is for surface of the gland, and this type of hatching is for the gland bush. This is your gland bush. This one. Similarly, this is also in this side. This one is your gland bush, and this one is the surface of the gland. Okay. Now come here. This is your neck bush. This one. This one is your neck bush. This one is your packing material, filling material, stuffed material, which I talk. Asbestos, yeah, fibrous material, yeah, some minerals which are able to absorb. It is being filled up by this thing. This is the main body part, main body surface of the main body of stuffing box, this hatching line. So follow the orientation of different hatching. So this is the main body, which is made by cast iron, main body part. This one is your packing material. This one is your neck bush. This one is the shaft, definitely neck bush. Okay. So here one component is here. This is neck bush. Another component is here. That is your main body part.
স্যার এই নেক বুশের নিচে ওটা কি? ওই
ওটা
একদম নিচে।
এইটা এটা
হ্যাঁ হ্যাঁ ওই।
এটা এটা shaft. Shaft has been extended over it. মানে shaftটা ভেতরে ঢুকে বাইরে বেরিয়ে গেছে।
আচ্ছা আচ্ছা।
Okay. This is the shaft. It ends here.
স্যার স্যার এই বলছি নিচের বডিটা মানে মানে ইউজ করছি কেন গ্ল্যান্ড দিয়েও তো একই জিনিসটা পারপাসটা ফুলফিল হয়ে যেত না, মানে আমি বুঝতে পারছি না
কোন পারপাসটা?
মানে একই জিনিসই জাস্ট এক্সটেন্ডেড উপরে নেক পোর্শনটা রয়েছে, কিন্তু এই জায়গাটা আমি যদি নিচের নেক পোর্শনটা বডি পোর্শনটা যদি না থাকতো গ্ল্যান্ডেই তো পারপাসটা সলভ মানে কি হতো কি মোটেই
না, গ্ল্যান্ডে পারপাসটা সলভ হতো না। গ্ল্যান্ডে পারপাসটা সলভ হতো, গ্ল্যান্ডে পারপাসটা না, তুমি মেইন বডি পার্টটা দিয়ে ভাবো। মেইন বডি পার্টে সলভ হতো, কিন্তু সেক্ষেত্রে তোমাকে এই হিঞ্জটা আবার তৈরি করতে হতো। মানে এটা দেখতে এরকম হতো, তুমি একটাই কাস্ট করতে হবে, মানে ডায়ামিটারটাকে তোমাকে রিডিউস করতে হবে। এখানে একই ডায়ামিটার তুমি যদি টানা দিয়ে যাও তাহলেই লিকেজ হবে।
আচ্ছা 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 বুঝতে পেরেছি।
মানে একটা ধরো তুমি টানা 50 ডায়ার একটা হোল, তার ভেতরে 40 ডায়ার একটা শ্যাফট। ওকে, 50 ডায়া হোল, 40 ডায়া শ্যাফট, and in between them there is bush. Yeah, in some places there is packing material. এটাতে লস হবে। তোমাকে কোথাও 50 রাখতে হবে, in some places it should be 45. Total 40 dia in the top portion, the hole should be 45, and in the bottom portion it should be 50. So there is a gap. This is a chance that 45 or 50. এখানে তিনটে লেয়ারের প্রোটেকশন হলো। দেখো প্রোটেকশন গুলো কি কি হচ্ছে। ফার্স্ট প্রোটেকশন ইজ নেক বুশ। ওকে, সেকেন্ড প্রোটেকশন ইজ দিস রিপেলেন্ট মেটেরিয়াল। থার্ড প্রোটেকশন হচ্ছে গ্ল্যান্ডেড ডায়া, যেটা ছোট হয়ে যাচ্ছে, তারপর গ্ল্যান্ড বুশ। সো দেয়ার আর 3 লেয়ার্স টু প্রোটেক্ট।
লিকেজটা একটু কম হবে যত আমি দেব, তাই তো?
লিকেজ হবেই না,
হবেই না।
তিনটে লেয়ার দিলে দেয়ার উইল বি নো লিকেজ।
আচ্ছা 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 বুঝতে পেরেছি।
একটা হলে লিকেজ হয়ে যাবে, লিকেজ হওয়ার চান্স থাকবে। বেসিক্যালি থিঙ্ক অ্যাবাউট স্টিম, ডোন্ট থিঙ্ক অ্যাবাউট ওয়াটার। স্টিম, if there is very small gap, this is a metal component. Okay, metal component shaft is rotating inside this component, shaft is reciprocating, কিন্তু কোনো স্টিম বাইরে আসছে না উইথ shaft। এর মানে তোমাকে ডিজাইনটা ভেতরে ওইভাবেই এমন ভাবে করতে হবে যাতে লেয়ারে লেয়ারে স্টিমটা আটকে যায়। if it passes through neck bush, then this packing material will absorb it, and if it passes, then again it will be prevented by here the gland.
আচ্ছা
The
আচ্ছা
gland bush. Okay,
বুঝতে পেরেছি।
so 3 layers are there. Okay, so এটা বলছিলাম the first component, this is the main body part. এই হ্যাচিং লাইন দেখো, সেম হ্যাচিং লাইন আছে মেন বডি পার্ট। নেক বুশ ডিফারেন্ট টাইপ অফ হ্যাচিং লাইন। এটা আমাদের ড্রয়িং এর বিষয় নয়, প্যাকিং মেটেরিয়াল। দিস ইজ নরমাল ওয়ান। দেয়ার উইল বি গ্যাপ, উইল শো ইট অ্যাজ এ গ্যাপ। ওকে, এখানে এই হ্যাচিং লাইন গ্ল্যান্ড বুশ, দিস হ্যাচিং লাইন, and this hatching line is for gland up to here. This hatching line is for gland. Okay. And other than that, there are nuts and studs. So this is the drawing. Now, what you have to do? You have to make working drawing of these following components. Working drawing of these following components: stuffing box, neck bush, gland, stud and nut. Stud and নাটটা তো দেওয়াই আছে এখানে, মানে স্টারটা দেওয়া আছে, নাটটা করতে হবে। Other than stud and nut, you have to separately draw this gland bush, neck bush, stuffing box. Working drawing means what? If it is required, then maybe top view, top view and side view. This arrow has been given. Yeah, there may be three view, top, front and side. Okay, with all the dimensions, you have to give it. You have to make it. And the dimensions you have to take from this drawing. Okay, that's why this can be called as a problem. So when we will draw the main body part, then yeah, here component has been written as stuffing box, which I was talking. I have taken this problem from a book and here it was written as stuffing box. I have not changed it. So that is the I was talking, that is the ridiculous one. This is component of stuffing box and this is being called as stuffing box. This is the main body part, the main box. Okay. So when you will draw it, you have to be taken all the dimensions which are given here. All the dimensions are visible here. Okay. You have to just take it from here and you have to make separate drawing. পারবে এটা করতে, না আর একটু কিছু দেখাবো?
স্যার একটু দেখিয়ে দিলেন ভালো হয়।
Acha. Okay. So as this is the first class, so I have already thought that I'll show you some extra things because this is the most easy one which we are going to draw in this course. Okay. First of all, I will show you an animated video where it will help you to visualize. Okay. I have chosen this video from YouTube. I'm just showing you. It will nothing but help you to visualize the thing. Okay. So this is the starting box. Okay. So two nuts. I open it, then this is the gland and here. Yes. You see, this top surface is oval in nature, means there is a curvature. You have to show this curvature in the drawing. When you will draw the gland, subsection view, when you will cut it and you will draw it, then you have to show this curvature because in the assembly feature, I told you that this is the place where we put the oil. The oil which will act as a lubricant when shaft will rotate. Yes, shaft will reciprocate. So that material loss will be minimum. For that purpose, we put oil here. Okay. So there is a curvature here. There is a curvature here at the bottom. Why? So that it can easily enter inside the whole of the main body part. Okay. You have to show it, these two curvatures. This is the feature of the gland. Okay. These two starts drawing are there. Start is very simple one. Two type of threads are there. One in bottom, another one in top. This is the shaft, and this is the packing material. This is the neck bush, and see the neck bush. The structure of the neck bush of the top is little bit angular curvature is there. Okay, and you have to show that curve in the component drawing. When you will draw the neck boss, you have to show it. Okay, why this? This is also to help the packing, so that we can easily pack it. The bottom of the neck boss is flat, but the top is little bit carved. And this is the inside feature. Inside feature is simple. Nothing is there. Just a hollow, flat hollow. Okay. So this is from thing. Now, definitely this will help you to visualize. One thing was missing there. That was the gland boost. They have not shown the gland boost. So you imagine that inside the gland, you will opening the gland boost. Okay. So gland boost, gland, main body part, and neck boost. Start and nuts are there definitely. So I will show you a figure where these components are there. Drawing components are there. Working drawing components. Working drawing. But the dimension is different. Okay. So you have to actually showing you a problem, means a solved one for a different dimension. So you have to make those drawings with these dimensions and in the AutoCAD. And in this class, you have to do vice versa. Vice versa means this assignment is assembled view is given to you. You have to draw the working drawing. Means front view, side view separately. That thing. In some cases, suppose in the next class, I may give you the working drawing of different components. You have to make the assembled one. Okay. So this is the vice versa which will be there. So in this problem, we will learn how to draw from the assembled to the working component. Okay. This is the drawing which we want, which a manufacturing unit want. The manufacturing unit who is going to make the stuffing box, you want this thing from the design team that you have to give me. This is called as working drawing of the components. All the components are here. 1, 2, 1, 2, 3, 4. Okay. Nuts are not here. And inside one, this one is gland. In two, this one is gland and this one is gland boost. Okay. So this is the working drawing. What the information we are getting from here? This is the top view, which I told you at the first, that this top view actually represents nothing. If you don't cut it, if you don't draw the sectional view, then if you draw the top view, nothing is understandable from this one. But you have to show this definitely, this top view when you will making this drawing components, because it will help to get some necessary information which I will tell right now. First of all, see this number 1. This is the main body part. Okay. Find out the diameter. 66. 66 is the diameter, which is not matching with anyone, any dimension here. But follow here 33. This 33 is being matched with this. Means that the bottom portion of the neck boss, the outside diameter, will be placed here. The height is 15. This height is 15. So it will be placed here. Up to this, up to 15, it will lie inside this portion. And this 6, it will go here. It will come here. The assembled view has been shown here. Okay. So 33, 33. Neck boss is coming here. Second, 42. The cylindrical portion of the gland. 42. And here 42. The gland will come up to here. If I just make this line here, the gland will come up to here, little bit inside. This 42, so 42, this is your 42. It is matching 42. 120, 120. The distance between center line of two start holes of your gland and your body part. 120, 122. It should be matched. 84 distance, it should be matched. Otherwise, the starts will not be fit inside it. Okay. And this thickness is 15. Okay. And mind here, this thickness is 15. And the start bottom portion length is 15. So stud will come here in this assembled view. Stud will go inside and it will end here. The bottom portion of the stud will end here. Okay. And the top portion will go from here to upper and this gland will be matched there like this. Okay. So this distance in the main body part between two center line, the distance between two center line in the gland, the distance of the flange in gland and main body part should be same. That's why you see 120 84, 120 84 is same for number 1 part and number 2 part, main body part and gland part. Where is the difference? Difference is the diameter of the hole. In the main body part, 66 42. 66 is the main body internal dia. Rest than 42 will be filled up by packing material. The shaft dia would be near about 40. Okay, so that will be here. Shaft 40 dia shaft can be used in the stuffing box. Not 40, sorry. Here is 33. So it should be 30. The shaft dia. You have to pass through this 33 neck boss. Okay. So this is another diameter. This is 33. This is 33. And it will have to go with it. You have to draw this all these parts for the drawing here. Okay. Now I want to show you that if the task was like this drawing has been given to you and the assignment would be like that, you have to draw the assembled view in the AutoCAD. Then what you will do? First of all, in that case, I will suggest that you will draw this half in this type of case because these total components are almost symmetrical. Okay. So this is the case where you will draw only one half, then you will mirror it. So all the features which is there in this side, you have to draw it at first with the start and all those things. Then you will do the mirroring. Then the major component will be made. I'm showing you. I have done little bit in AutoCAD. I was just doing it here right now before this. So actually, how it will look like. Okay, so here I am showing you these things to understand one important thing. You see, two hidden lines are there. It means that two holes are there. Okay, one is of diameter 12, another one is of diameter 13. Okay, so why this 12? Why this 13? Because you see here in the drawing. Okay, so you see there are two lines. Two lines means one hole is there, one bigger hole, one smaller hole. The smaller hole diameter is 12. Smaller hole diameter is 12 because the stud is M12. The thread of the stud is M12. M12 is the notation. I think you have already learned it in your first year. M12 means major diameter is 12. This is the style. This is the designation style to designate any thread. M12, M16, M24, M8 like that. It represents the major diameter of the thread. You know, in a thread there are two diameters, major dia and minor dia. So here major dia is 12. Okay, we will not consider anything. But when major dia will go inside it 12, then already there should be a hole. And from where we will get it, that hole dia? We will get that from here. Here. This is the top view. One top view is here. You see two holes are there. One top view is here. So
Yes.
M12 is the smaller hole. So bigger holes kitna? Bigger holes you will get here. 13. So this is the hole which is already there. If you come here, you see this is how much. Wait, this is how much. 5 is 16. 5 16 means major dia is 16. Okay, major dia 16. But the whole dia is given 18. This is the same information which is here I was talking. The major dia is 12, but you have to make a hole here with 13 so that that thread can go inside. Already tap is there, the thread can go inside. You can see here there is a thread tap already there. Okay, so it is definitely little bit larger than this major dia, so that is 18. That's why two lines have been created. One is for 12, another one is for 13. And it has been drawn for this one, 12 and 13. Okay. This is one information which I am giving you. It is important. You have to keep in mind this thing when you will draw the component. Another thing which I should tell you, that is this one. You are seeing here 15 degree. You are seeing here 15 degree. I already told you that there is a curvature in the neck boots. You have seen in the YouTube video. There is a curvature in the neck boots, top
Yes.
one, so that it can properly packed. So from where, how we will draw that curvature? How we will draw it? It is very simple. Very simple means that I'm just doing it arbitrarily. I don't know whether I have done it or not. So if I draw a line of 15, it is 15, 33, 24. Okay, 33, 24. And 42, 21. Okay, I will just draw this thing and I will make it offset. This. Now I will draw a line of 15 degree here. So I am not following the proper dimension here. That's why it is not touching properly. If you do it, it will be touched properly. Point is that here the feature which I am trying to see, this feature will look like this. You have to draw a 15 degree. You have to draw a 15 degree here, and it will be touched here. This is the case. This is the case. This is the 15 degree, and this angle which they are talking about, and it will come here, and it will come here. So this same feature is available here also, 15 degree. So when you will draw this component, here the angle is given, here the angle is not 15, rather it is 30 degree. Okay. So when we draw it, you have to be careful about this thing. Here it is 15 degree in the working component. So you have to show it here, the angle. Okay, you have to draw this component as it is 30 degree. have to show here. And here there is a radius because this is the oval shape of the gland where I tell you that we put oil. And this also should be there in the gland bush. This is actually the gland bush and this is the gland. That's why it is 46, you see. This die is 46, little bit higher. But it is perfectly matching with this. This is the 12 and this is the 12 radius. So you have to match all those things. When you will draw the component, all the components dimensions are connected with each other. You have to be careful about that thing. So I think with this much information, you can do it. Yeah? Can you solve it? Not half section, this one.
Yes, sir.
So should
Okay.
we draw those individual drawings on
Sir,
AutoCAD?
Ha. You have to draw a working drawing like this.
In
This
AutoCAD? Okay.
in AutoCAD, definitely AutoCAD. এটা এগুলো আগে হাতে ড্রয়িং করতে হতো, দ্যাট ওয়াজ ভেরি ডিফিকাল্ট। ডিফিকাল্ট মিন্স নট ডিফিকাল্ট, টাইম টেকিং rigorous. In AutoCAD, this is simple. If you have confidence in AutoCAD and if you know how to use different modifying tools in AutoCAD, this will not take much time.
স্যার এইগুলো স্যার AutoCAD এ আঁকবো আমরা, স্যার DWG ফাইলটা স্যার দিয়ে দেবো, তাই তো?
না,
আচ্ছা,
প্রথমেই বলেছি আমি
A3
that
ফাইল।
you have to convert it into PDF, A3 template PDF with title block. My suggestion is that at first what you will do in AutoCAD, okay, I'm showing you. What you will do, you will make a layout with A3 template and title block will be there. You know how to do it. You told me
yes,
that.
sir.
Okay.
Yes, sir.
So you will make that A3 template with a title block. Already you will keep it in your desktop. Okay. A blank template with title block where all the informations are written. So that when you will do the drawing, suppose you have done this drawing, then you will bring that. Then you will bring that template here and automatically you will put it into layout, and here from the layout, if everything is fine, you will check from here page setup manager that what you are trying, plot size is landscape, drawing to PDF or not plotter. When everything is fine, then you will go here and you will export it as PDF and you will submit that PDF with title block in the assignment section. বুঝা গেছে?
Yes, sir.
Okay, so আমার ধারণা, if you have any question regarding it.
স্যার ওটা কি 16 ট্যাব না 6 ট্যাব?
না, ওটা 16
আচ্ছা
M16 না ওটা।
আচ্ছা
So, তাহলে ওই ইন্ডিভিজুয়াল ড্রয়িং গুলোই করতে হবে, তাই তো?
হ্যাঁ, কোশ্চেন হচ্ছে এটা। কোশ্চেন ইজ দিস: মেক ওয়ার্কিং ড্রয়িং অফ দ্য ফলোইং কম্পোনেন্টস অফ দ্য গিভেন স্টাফিং বক্স। স্টাফিং বক্সের একটা ওয়ার্কিং ড্রয়িং বানাতে হবে। নেক বুশের ওয়ার্কিং ড্রয়িং, গ্ল্যান্ড বুশের ওয়ার্কিং ড্রয়িং, গ্ল্যান্ডের স্টাডের নাটে, স্টাড এখানে দেওয়াই আছে, এটাই করতে হবে, আর নাট। এই ড্রয়িংটা করতে হবে না। দ্য ড্রয়িং হুইচ ইজ হিয়ার ইউ ডোন্ট হ্যাভ টু ড্র ইট।
স্লাইডে 10 নাম্বার ইয়েতে যে ফিগার গুলো আছে ওইগুলো আমাদের ওয়ার্কিং গুলো করতে হবে।
হ্যাঁ, এটা অন্য ড্রয়িং এর জন্য কিন্তু এই হ্যাঁ হ্যাঁ
হ্যাঁ।
হ্যাঁ হ্যাঁ এই ড্রয়িং এর মতো এই ড্রয়িং এর ডাইমেনশনের রেসপেক্টে এইরকম ড্রয়িং বানাতে হবে। আর এইরকম জিনিসটা আমি আজকে দেখিয়ে দিলাম ফার্স্ট ক্লাস বলে, পরের দিন থেকে দেখাবো না। পরের দিন যে কম্পোনেন্টটা ডিসকাস করব তার ওয়ার্কিং কম্পোনেন্টে কি কি থাকবে এটা কিন্তু আমি এরকম ভাবে দেখিয়ে দেব না, কোনটা কোনটার সাথে ম্যাচ করছে, কোন নেক বুশটা, আমি সব ডিটেলস বলে দেব, কিন্তু এরকম ভাবে ভাগ করে দেখাবো, সেটা তোমাদের করতে হবে। বুঝে গেছে? এটা আজকে প্রথম দিন বলে আমি সব দেখিয়ে দিলাম, যে এটা আরেকটা কম্পোনেন্টের এরকম হবে ওয়ার্কিং ড্রয়িং ব্যাপার, বা অন্যটাও হতে পারে। পরের দিন আমি এই কম্পোনেন্ট গুলো দিয়ে দেবো, আই উইল গিভ ইউ অল দিস কম্পোনেন্টস and I will tell you that draw an assembled drawing. Actually, assembled drawing করাটা easy. Why? I tell you. First, you will draw this thing as it is, all the dimensions. Okay. Now you will see that which dimension is matching with what. আর অলরেডি কোন কোন পার্ট থাকবে, কি কি কম্পোনেন্ট সব অলরেডি আমি বলে দিয়েছি বা বলা থাকবে তাতে। So you will just move in the AutoCAD this part here. You will draw it separately and you will move it and you will place it. In this way, you can make the assembled part. That is very simple. Assemble করাটা easy অনেক। You will draw this work. Actually, you people also can do. মানে তোমরা যখন ওয়ার্কিং কম্পোনেন্টটা বানাবে প্রত্যেকটা ইন্ডিভিজুয়ালি, then you can move those components and move as per the style which is there. Then you can easily মানে বুঝতে পারবে যে অ্যাসেম্বল করাটা কতটা সহজ। আই এম জাস্ট গিভিং ইউ অ্যান এক্সাম্পল। সাপোজ দিস ইজ দ্য ড্রয়িং অফ দ্য কম্পোনেন্ট 3, then what you have to do, you have drawn it separately, then you will move it, suppose this is the base and you will move it like this and you will place it here. একটু সরে গেছে বলে হচ্ছে না, অন্য কোথাও প্লেস করে দিচ্ছি। ওকে, তুমি এখানে প্লেস করে দেবে, যেখানে প্লেস করার কথা এখানে প্লেস করে দেবে and জুম ইন করে একবার চেক করে নেবে যে ইট ইজ প্রপারলি প্লেসড অর নট। অ্যাকচুয়ালি এটার একটা সেন্টার লাইন থাকবে, এটার একটা সেন্টার লাইন থাকবে, সেন্টার লাইন আর সেন্টার লাইনে প্লেস করে দিলেই হয়ে গেল, অ্যাসেম্বল হয়ে যাবে। If all dimensions are right and you can make the separate drawing, you can move accordingly and you can make that assembled view. You will get the view like this. When it is not cut, you will get a view like this. I tell you, you will get a view like this. This one. This stud, if you move this stud in AutoCAD, suppose this drawing is in AutoCAD, if you move it and if you place it, this center line and this center line, if you match, or if you use coordinate system, then also it will be perfect. You can bring it here, then use coordinate system, give the coordinate, it will perfectly placed with it. So from all this drawing, making this is just 5-minute task. Clear? বুঝা গেছে?
Yes, sir.
ইয়েস স্যার।
আচ্ছা, তাহলে আমাকে একটা জিনিস বলো তো, তোমাদের গ্রুপে কত থেকে কত রোল নাম্বার আছে? A3
রোল শিটটা তো সন্দীপ পাঠাসনি স্যার?
না, ও পাঠায়নি, ও পাঠিয়ে দেবে। আবার এখন বলো না তুমি কত
আচ্ছা।
থেকে কত আছে।
আমাদের আছে হচ্ছে 210 থেকে 018, মানে কিছু ল্যাটারাল স্টুডেন্ট আছে।
বুঝলাম না, 210 থেকে 018 বললে হবে না, রেগুলার
210
স্টুডেন্টের বলো আগে রোল নাম্বার কত থেকে। ব্যাস, আমি এইটা আগে জানতে চাই, ল্যাটারাল আমি নিয়ে নেবো পরে। 210 থেকে 233। আমান রাজ,
Yes, sir.
রোল নাম্বার কত?
220.
অর্ক,
Sir, 224.
দৈপায়ন পাল,
213.
এনায়েত আলী,
215.
Rishabh Hori,
231.
Indranil বিশ্বাস,
173.
173। এই তো বললো 210 থেকে 233 আছে, তুমি এই
আচ্ছা,
লোকের তো।
এটা আমার আগের ইয়ারের
Sir, Pratish Kumar,
ওকে,
212.
কৃষ্ণ মিত্তাল,
কৃষ্ণ মিত্র
বলো।
স্যার প্রীতম মিত্র 219।
আমি যাবো তো
Sir,
তোমাদের কাছে, ওয়েট করো না। কৃষ্ণ মিত্তাল, আর ইজ দেয়ার?
Sir, Pratish Kumar, 212.
I have not called you. I am calling Krishna Mittal. I will come to you, Pratik.
Yes, sir. Yes, sir.
বলো roll number.
211.
Pratish Kumar.
Yes, sir. 212, sir.
Okay. Pritam Mitra.
Yes, sir, present 219.
Shomir. Shomir, are you there?
Yes, sir.
Roll number.
Sir, 30211120117.
Lateral entry.
Yes, sir.
Last 3 digit बताओ.
017, sir.
017. Sandeep Kumar Sahu. Sayan Chatterjee. Microphone is not working. Soharto Rai. Soharto Rai.
227.
Somadev Bhattacharya.
218.
Upan Rana.
Sir, 229.
Shubhankar Vishwas.
At 216.